In this video, we'll learn how you can use simple materials to find the order of the reaction with respect to dye in the reaction between dye and hydrogen peroxide. We'll first take 100 milliliters of water and place it against a red background. We'll add 10 milliliters of 1 molar sodium carbonate and 10 milliliters of 3% hydrogen peroxide. After mixing well and placing a timer in view, we'll open a red, green, blue analyzer app on a smartphone and place the assembly in view of the phone. When the experiment's running, we'll be monitoring the red light that's coming through the beaker and into the cell phone. We notice that the initial value is 223. To initiate the reaction, we're going to add 1 drop of blue food dye and simultaneously start the timer. Now the blue dye starts to react with the hydrogen peroxide in the beaker and it goes to colorless products. The red light traveling through the beaker gets blocked by the blue dye. We can easily see that this is the case because the R value recorded by the cell phone has significantly dropped. Now as the reaction proceeds, the blue dye fades, which allows more and more red light to travel through the beaker. We see here at 1 minute the R value has risen to 8. For each R value that we record, we'll also calculate the absorbance as shown on the screen. We'll continue to do this at 15-second increments all the way up until the R value gets above 100. We see here at 1 3/4 minutes, the R value is 61, making the absorbance 0.56. Let's watch and record the data as the reaction proceeds. Okay, we're going to go ahead and analyze the data. As you can see here in column A, we have the R values obtained at each time increment in minutes, which is listed over here in column B. We want to know the absorbance at each time, and we're going to calculate the absorbance at each time t with this equation over here. So the absorbance at time 1 minute is going to be equal to the negative log of the R value at 1 minute divided by the R value of the blank, which was 223. So we see that the absorbance at 1 minute is about 1.45. Now the absorbance is proportional to concentration. We're going to go ahead and fill down, and now we've quickly calculated the absorbance at each time increment. 1.02 or 1.03 is the absorbance at 1 1/4 minutes and so forth. Now the absorbance is proportional to the concentration. So let's take a graph of absorbance versus time to get an idea of what happened to the concentration of the blue dye with time. That's this graph that you see here. We see that the absorbance dropped with time, which tells us that the concentration of the blue dye also dropped with time, and that makes sense because the blue dye faded as the reaction proceeded. Now what we're really interested in is whether the reaction is first order with respect to the blue dye or second order with respect to the blue dye. Here's how we're going to test that. Look at these equations over here. This equation is the equation for a first order dependence on the blue dye. So what we want is we want to plot the natural log of the dye concentration at various times. If If we do that and get a straight line, that's indicative that we have a first order reaction. Now again, since the absorbance is proportional to the concentration, let's just go ahead here and calculate in cell D2 the natural log of the absorbance concentration at 1 minute. We're going to fill that down, and now we're going to try to get a plot of the the natural log of the absorbance versus time. It's the second series that we're interested in, so I'm going to go ahead and eliminate this first series, which is just the concentration of the dye versus time, or the absorbance versus time. And we see this plot, each of these points represents the natural log of the absorbance at each time increment. It looks pretty linear. Let's go ahead and test this. I'm going to add a trend line. I'm going to check out what the r squared value is for my trend line. And if I look here, I can see that the r squared value is about 0.94. The closer this value is to 1, the more the data fit to an actual line. That's not too bad. But maybe the second order plot is better. Let's test it. We're going to remember that r squared for the first order case is 0.94. So I'm just going to type that right here. Now we'll do the second order test. We're going to use this equation, 1 over the dye is equal to 1 over the dye initially plus kT. We're going to use this equation to test to see if the reaction is second order with respect to the dye. So here in in cell E2, I want to calculate 1 divided by the absorbance, and we'll fill this down. And we'll test to see if a plot of 1 over the absorbance versus time is linear. Now in this case, we're interested in series 3, so I'm just going to go ahead and eliminate the first 2 series. Let's do a test here to see if the r squared is better. And indeed it is. If we look at the r squared value for this particular plot, we see that it is a 0.98. That's closer to 1. That tells me that the data seem to indicate that this reaction is second order with respect to the dye concentration and not first order.